Why the Atlantic and Pacific Oceans don't mix. Did you know that about 70% of the Earth's surface is covered by water, which is 361,132,000 kilometers? 2. When you look at a map of the world, the oceans and seas are easily recognizable, and you might think they are merging. There seems to be just one huge ocean that people in different countries have given different names to. This is not true. In fact, the boundaries between the 5 oceans of the world are very clear. You may be surprised to learn that despite the fact that they are made up entirely of the same components, the bodies of water do not always blend together if you ever get to look at the point where the world's 2 largest oceans meet, namely the Pacific Ocean and the Atlantic Ocean. The southernmost point of South America, called Cape Horn, you will see a very strange phenomenon. The waters of the Atlantic and Pacific Oceans refuse to mix. What's even more impressive is that the boundary between these 2 oceans is like a line between 2 worlds. The darker waters of the Pacific Ocean are next to the lighter waters of the Atlantic Ocean, and it looks absolutely astonishing as this boundary continues up to 800 kilometers, which is known as the Drake Passage. So, why does this happen? Watch the video to the end and you'll learn a lot. Not only are there different kinds and types of water in nature, but also different compositions of water. The Atlantic and Pacific Oceans are different in density and chemical composition, salinity levels, and other characteristics. And this is what forms a barrier between them, making it difficult for them to mix. You can easily tell from the difference in colors that the water of the 2 oceans is far from being the same. The boundaries between 2 bodies of water with different physical and biological characteristics are known as ocean wedges. One of the most impressive types of ocean wedges is called a halocline. When 2 bodies of water with significantly different salinities come together, a halocline forms because the bodies of water refuse to mix, which is spectacular in itself, and is what we see when the Atlantic and Pacific Oceans meet. This phenomenon was discovered by the famous Jacques Cousteau when he was deep diving in the Strait of Gibraltar. A halocline is formed when water in one ocean or sea is at least 5 times more shaly than in another. Now you could argue that according to the basic laws of physics, the denser fluid should be below and the less dense fluid should be above. According to this theory, we should have water from the Pacific Ocean flowing on top of the Atlantic Ocean, meaning that the boundary between the 2 oceans would look like a horizontal line rather than a vertical line, but clearly this is not the case. So why doesn't it happen? The answer is, first, the difference in density between the waters of the Atlantic and Pacific Oceans is not so great that one sinks and the other rises this, and prevent in their mixing. However, it is sufficient to prevent them from mixing. The second cause is inertia. One of the forces of inertia, known as the Coriolis force, affects the motion of an object. One example of the Coriolis force is seen in the rotation of the Earth. As the Earth rotates, all moving objects on the Earth are affected by the Coriolis force, veering off their course. As a result, an object on the surface does not move in a straight line, but is deflected clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. Because of this, the direction of flow of bodies of water in the Arctic and Southern Oceans is different. This also prevents them from joining together. But there is another difference between these bodies of water, and that is density, which affects surface tension. The 2 oceans have completely different surface tension, and this also prevents them from mixing. Thus, the Arctic and Southern Oceans do not mix with each other due to different water densities, currents, and surface tension. That's how there are places where seas, oceans, and rivers meet on our planet. It looks incredible. There is a boundary between them, and it is as if their waters do not want to mix with each other. So why does it happen? The merging lines are sometimes visible to the naked eye. Spoiler, it's not just the different densities of the waters. According to one version, Jacques-Yves Cousteau first drew attention to this phenomenon while exploring the waters of the Strait of Gibraltar. In 1962, the Mediterranean Sea and the Atlantic Ocean intersect there. The scientists noticed that not only the color, but also the temperature of the waters differed. Then oceanologists found out that such boundaries are visible because of the big difference in salinity. The waters of oceans, seas, and rivers may also not mix due to differences in surface tension, as well as differences in temperature or chemical composition. It is erroneous to say that water bodies do not mix at all. It happens partially, but the visible boundary between the communicating water spaces is still noticeable. By the way, in some cases this phenomenon is not static. Where else can you see it? You don't have to go to the meeting point of the Pacific and Atlantic Oceans. For example, in Denmark, an invisible wall is created by the Baltic and North Seas. It looks no less spectacular, all shades of blue in one place, dark on one side, turquoise on the other. You may even want to dive to make sure there is no wall, but it is better not to because of very strong currents. What color is the open ocean? It's impossible to put into words. The color of the water is constantly changing. It depends on the light, the depth, and the number and size of organic and inorganic particles suspended in the water. The sea is not always blue. Most seas are named for the color of the water. Northern seas have a cold, dark green color. In the tropical zone, a gentle blue color. Near the coasts, especially at the confluence of rivers, the water is brown or yellow, and in stormy weather hurricane winds carry huge, gloomy masses of water of lead gray color. So what influences the color of the sea surface, giving it a particular color? The color of sea water refers to optical properties and has been studied for many years. Back in 1817, Russian captain O.E. Kaspu wrote, "The external, eye-pleasing properties of sea water, namely its color and transparency, deserve the attention of the navigator. Regarding the former, it is necessary to notice to what extent the strange or variable color of the sea comes from the change of depth, from the color of the sea bottom or the sky and clouds, from the light of the sun, or from foreign substances on the surface of the water. So what is it that colors seawater so differently? The color of seawater depends on many factors. The blue color of the sea, like the blue of the sky, is due to the inherent properties of the sun's rays. When a sunbeam penetrates the water, the shortest rays of the solar spectrum, the blue rays, are scattered in all directions, giving the water a blue hue. The color of the water depends on the direction and brightness of the sunbeam. Therefore, the color of the sea surface, perceived by the observer's eye, is composed of light rays scattered in the water and coming out of it, and reflected by the sea's surface of daylight, and also depends on the angle of view of the observer, from the conditions of illumination, cloudiness, excitement. When looking far away, the angle of vision decreases and the eye gets less light coming out of the sea, and more light reflected from the surface. So in the distance, the sea has a color close to the color of the sky. In cloudy weather, gray. In clear weather, blue. During sunset, the bright blue water slowly turns golden, as the sun is at a much lower angle to the horizon. At full calm, the sea seems whitish, and the excitement of its color is more intense, as the eye of the observer gets part of the light coming out of the water. The color of the sea is perceived in pure form when the observer looks at the water vertically downward and the eye does not get reflected rays from the surface. See a brown or yellow color. For example, in the Yellow Sea, a huge amount of clay particles carried by the rivers color the sea water yellow, and in the Red Sea periodically develop brown, microscopic algae that give the water a red color. Sea water can be written about endlessly. In the palm of your hand it is transparent and has no color, but in the ocean the water takes on many shades and colors. For most people who see the sea from the shore, it has a blue color. But for those who sail the vastness of the world ocean, it strikes with its variability. You can admire the sky blue surface of water for probably an eternity. Do you know why it has such a color and what can determine its depth, saturation, and tone? In the 19th century, a geographer from Switzerland, F.A. Trout, invented a special device that measured the color of water using a scale of hues created from chemical solutions. This scale is called a xanthometer. The scientist proved what today already seems obvious. The color of water is determined by its ability to transmit and reflect the colors of the solar spectrum. For example, snow reflects white color. Ice is transparent because it lets the sun's rays through, and ocean water reflects a blue hue in the spectrum. In 1883, another scientist from Belgium, Spring, conducted experiments with distilled water. His experiments showed that in a closed tube, even distillate sometimes has a blue hue derived from the color spectrum. The scientist also proved that water absorbs the red and dark colors of the spectrum, but the blue ones pass through. for some time acquiring a blue hue. Also, the color of sea and ocean water is affected by the chemical composition of the waters. Sometimes ocean water can appear red or olive in color. This is due to algae, which can color the ocean in very original colors, such a blue sea. Why sea water has such a pleasant blue color, if by nature it is transparent? After all, even if you pour sea water into some glass container, it will also be completely colorless if you think that it acquires this color. Because the surface of the water reflects the blue sky, you are mistaken. The blue color of the sea, which is pleasant to the eye, is the result of the scattering of sunlight by the sea water column. It transmits light unevenly. Short waves are better scattered and long waves are somewhat worse. Short wavelengths have the blue part of the spectrum and long wavelengths have the red part. In a decanter, you are looking at a thin layer of water, so the difference in the transmission of rays is not noticeable at all. And in the sea, the result of scattering of sunlight by many meters thick sea water is observed. By the way, the best it reflects not blue, but violet color, even better, ultraviolet radiation. This explains why on the seashore the risk of getting a sunburn is higher. Another problem of vacationing at sea is dehydration.